Hello, I'm Gail, and welcome to Discover Easton. I have to tell you, we have a very interesting show for you today. And standing here beside me is John Holbrook, the owner of Easton Machine Company. Thank you very much for having us here.
Oh, thank you for stopping by. We're happy to give you a tour.
Yep, and I'm very, very excited about this. And so here we are on Elm Street in Easton, and we'd like to talk about the history of how did this whole begin? How did the whole company begin and everything?
Okay. Well, my father was a machinist, and at one point he decided that actually there was a machine shop up on the corner of Elm Street and 138, and he worked there for a while, and the company ended up being sold, and he took that opportunity to buy some equipment and start a company. So he set up the equipment in one side of our two-car garage here on Elm Street, the house that I grew up in, and eventually it turned into Easton Machine, and we've been here. I think he started in '64, so we've been here since 1964 in the same location, and employed up to 25 people.
Really?
Yep.
So the building was not as large as it is now when it first began?
Right. It's been kind of a process over the years. We started, I think, with a 20 by 60 building, and we added a little bit more onto one end, and then we added the office here on the front, and we added a little bit off the back, and then around 1999, 2000, we added on the metal building and finished off the office area. So it is what you see here today.
Wow. So how large would you say, approximately, how large is the whole?
About 15,000 square feet.
Wow, yeah. 15,000 square feet.
Yep.
That's impressive.
Thank you.
That's amazing. So is there anything else you want to say about the whole history of it, and just how the company, how has the company changed since 1964 as far as, materials and all that and getting a hold of them?
Sure. We've my father started the company with what they called automatic screw machines, which were a cam-operated mechanical type of machine, and we bought our first computerized machine back in 1989. I came on board full-time in '84, and really then that kind of began the transformation. But we've, I think leading up to 2000, we had a lot of companies locally. We still did a lot of work in the shoe industry for companies over in Brockton on a lot of the shoe dies and that type of tooling. And we did a lot in electronics for Alden Products over in Brockton, and used to be component manufacturing down in West Bridgewater was a large company, but now a lot of those companies have been sold out, bought by larger companies, kind of moved their production elsewhere, and we've kind of shifted into more high-tech industries from that. So we're doing a lot of hydraulic and pneumatic components, but also into some medical components. We have, we actually manufactured some components through a customer of ours, Parker Hannifin, to Ford Motor when they were working to manufacture ventilators. And we also have a company that makes robotic lab testing equipment that was utilized by Moderna for the vaccine.
Really?
So we've been pretty busy right through the whole COVID pandemic.
Really?
Yes.
Yeah.
We were open the whole time, and
were you really? I was going to ask that.
Yeah,
how
we were.
COVID.
It's been, it's been pretty stressful for us. I know it's, coming every day, not, being concerned about something that you can't see, and we're not really exposed to the public, so we didn't have that part of it, but it was still, it was still pretty difficult for a lot of the employees.
Wow. Now, how about as far as I know that many companies are experiencing shortages of materials. Do you find that at all? Is there a certain material that you're having trouble with?
We do, a lot of materials, and we're just now having to buy a lot of materials as soon as they're available. If I know that I need something and it's available today, we have to buy it today and just put it in inventory, where we're, we were used to, working more along a just-in-time, where I could, if I knew I needed the material next Tuesday, I could order it Monday and it would be here Tuesday.
Yeah.
And now we're buying material. I have a job that's going to start in the fall, and I just bought $10,000 worth of raw material to put on the shelf, so I know that I have it in the fall.
Time for the fall.
And we have one kind of not really crazy, but kind of a unique material that at times can be a little bit difficult to find. That particular material has been on order since October of 2019, and we haven't been able to get a hold of it yet.
You're kidding me.
No, we've yeah, it's been a struggle, and a lot of the standard materials that we utilize, we haven't been able to get a lot of them. A lot of the small diameter materials are not manufactured here in the States. They're always imported because there isn't enough volume or weight to them to justify manufacturing here.
Okay. Yeah.
So with the shipping and shortages and everything that's going on, it's been very difficult to get those materials in.
Wow.
And we've had to adjust and tool up for different size materials that we haven't used in the past. So it's a constant struggle. And you know, just when you think you have, the supplier has this material and I'm going to order these two materials combined with that to try and save on the freight a little bit, which is going crazy. You call them up the next day, and oh no, that material's gone. We sold it. It's so it's can be very difficult. Certainly a challenge.
That must be so frustrating.
It is.
Seriously, because then you have the customer going, okay, so where's my stuff,
Exactly.
right? So wow, that's insane. And do you know of what other changes? You know, so you've been doing this since 1989, 84.
Yes.
Wow. So I mean, a lot of changes. Have you always, growing up in the family business, did you feel like you wanted to do this? Is this something that you're doing it kind of because it's family?
It was never the plan.
Really?
So I remember working here. I know when we got snowed in for the blizzard of '78. Once we got power back, I was working on machines at that time.
Yeah.
And I do remember. I don't know the year, but I had worked here one time. I was on some parts, deburring some parts with both of my grandfathers. They just both happened to be working here that day, kind of helping out. So I do have a lot of memories that go back pretty far.
Yeah.
But I really thought I was going to be more involved in engineering, and I think when I was getting out of college, CAD was just kind of on the verge of happening.
Yep.
And, I thought I would get more into that to that type of thing. I actually had a engineering drawing class at Oliver Ames that with Juan Vampire was my teacher, and he was fantastic, and he really got me interested in the drawing and doing all that type of engineering thing. And he graduated from Wentworth Institute in Boston, which is where I ended up going. So
Great.
it was it was a great experience being in that class. But I never really thought until I got into Wentworth. I had the opportunity to do some co-op semesters and work different jobs, and I think I ended up here out of deciding what I didn't want to do. I learned what I didn't want to do and ended up here. That maybe that's not so bad. So
okay, good.
Wow. I have enjoyed it, and it really has changed a lot. We didn't have any computers when I started here. Everything was, even in the office, everything was just handwritten, and now everything's on the computer. We're logging in every day. Everybody in the shop they're logging in their production numbers, and computers tracking their time for efficiencies. And
so everybody's involved in the computer part of it.
Absolutely.
Wow.
They're even the machine operators. The computers are all programmed with totally CNC. They're using Excel spreadsheets to track all of their tooling, the tool life times. We have a lot of repeat jobs, so we can really predict how long a tool is going to last when we have to change them from a quality standpoint. So
that's really good.
Yeah, it's pretty interesting stuff, and it has come a long way.
Yeah, that's
certainly.
great. Now, you mentioned at school, you had that class, and so I thought I read something about your company being involved in the STEM program and things like that. Can you expand upon that a little bit?
Sure. Paula Martell that works for us, she's our HR manager, and she and Paul Diamond, our vice president, who's also from town, all of us are very involved in doing different STEM activities. They've done a lot, I think, for the elementary school, middle school programs, really different projects.
Really? So that young?
And start them off early.
That's
and
awesome.
They've been involved we do a lot with the Children's Museum in Easton. We do a lot with the Children's Museum, so we try and donate to them, and they have a lot of STEM activities. And just trying to promote whatever we can. And I know Paul and Paula are both on multiple advisory boards from Southeastern to BP, and Mike, our production manager, that I'll introduce you to in a little bit, he's a graduate of Diamond down in New Bedford, Fall River area, and he's on their advisory board for their machine shop. So we're all very active trying to promote the industry, and I think that manufacturing has kind of a stigma of being down and dirty and whatnot, but as you'll see when you go through, it's really totally different now with the computerization and everything that we're doing. It's amazing, and we used to have to handle the parts a lot. We would blank a part out. It might have a milling operation, a cross drilling operation, and many different setups on many different pieces of equipment that would have to go through. And now, to overly simplify it, we put the bar stock in, it machines the part complete, and a finished part comes out. So,
Come on.
Yeah.
Really?
Oh, it's amazing. Yeah.
Wow.
Yeah.
Oh, that I cannot wait for the tour. I bet you can't wait for the tour too. And yes, we will be having a tour. So this is quite exciting, and I love the fact that you're bringing it to such young kids, because you never know where their talent is, right? Until they experience and they see this. So you know what, I really like this. Yeah. So that's great. Thank you so much.
Just like a video game.
Yeah, right? Yeah, just like a video game. Yeah, fun.
I think that wraps it up. I can introduce you to Mike, and he can give you a tour and show you what we're doing firsthand.
Oh, that's fabulous. Fantastic. Thank you.
All
right,
Great.
Let's go. So here we are. We're about to begin our tour, and we are here with Michael Medeiros, and he's the production manager. So thank you very much. And where do we start? So if you could tell us from start to finish how this whole thing happens.
Well, I was thinking we would start out here in receiving, do a brief overview of what happens in this department, and then I would bring you guys out into the shop. There's 3 primary pieces of equipment that we use, different types of equipment.
Okay.
Kind of showcase each of those with you, and then continue the tour into our finishing department, end in assembly, and kind of give you a general overview of the entire facility.
Great. So what kind of materials generally do you work with?
It's a variety of materials. So material science in itself is very confusing. For steels. I mean, there's probably easily over 1,000 different steels available, but we put some out on display so that you guys would be able to see the similarities between them.
Oh yeah.
The majority of what we're working with is going to be steels and stainless steels, aluminums, brass, composites, which are variations of plastics that might have glass-filled resins in them and such. So if we're looking at these here, this lighter color bar is an example of aluminum. And aluminum in and of itself has several different alloys, different aircraft grades. And the yellowish colored bars are brass in just different shapes, square, hex. This will be an example of some steels that will run.
Ooh. Okay.
And again, some more aluminum on the other side. So I think just being able to see that, so the viewers will have an idea of what we have going on out there.
Oh, thank you. Yeah.
Yep. And then everything else we keep cataloged in this stock rack. I don't know if you guys had dug into it out there, but we're ISO certified. So keeping traceability of everything is critical to the business. So everything is set up here in the rack. All the different alloys are tagged appropriately, and that information is also backed up in our software as well on the computer.
Okay, good. That's impressive. That's really impressive. What is the most? Is there one material that's more challenging to work with than the other, or is it?
Yes. Definitely certain grades of your stainless steels are going to be a lot harder. Like brass, for example, is probably one of the easiest alloys. Leaded brass is one of the easiest alloys. But this bar is going to cut far differently than that bar.
All right.
So yeah, once you start to get up into your tool steels, and I want to say not your 17.4 alloys. Sorry, that's going to happen 4 more times.
Okay.
But yeah, there's definitely the stainless steels pose a challenge. We do some titanium work here, which the particular grade that we do for medical work is very reliable, easy to machine. So
Okay, so there is a difference. There's definitely a difference.
definitely a difference. Yep. Yeah, and you have to kind of understand all those differences before you leave this room and get over there, because it's a much different environment if you don't know the material,
really?
what you expect for a result on your machine if you haven't planned that out thoroughly. Could be the difference of good part, bad part. So.
Really? Wow, so there's a lot of knowledge.
Oh yeah.
Wow.
It's an industry that you never really stop learning.
Really?
In so.
Huh. That's great.
The only other things that we typically do out here is some of the bars need to be prepared a certain way to go in the machine. So
Oh, really?
I guess, for example, we have these angles cut on the bar, which are just, we
look at that,
refer to them as
yeah.
chamfers. That helps to guide the bar into the machine.
Okay. Oh, right, so instead of just flat like that, you have a little curved part.
Yeah, and
Okay.
I think it'll all tie together once we get out there and look at the equipment. You'll
Okay.
see why we do these types of things.
Sure.
So,
Great. Good.
so you guys ready to head that
Yes,
way?
definitely. Let's do the tour.
All right. So this job that we're about to look at, running aluminum. I don't know if
okay.
you were able to tell just by looking at it, because we have that
kind of
extensive coursework out there. But the material's in 4-foot lengths.
Yep.
We load it into this device, which is a bar feeder. So when we come around here, yeah, we tried to make some room so you guys would be able to capture some of it. So this is the first of the 3 primary types of equipment that we have. This is called it's a CNC Conventional Lathe, where I brought my trusty pointer. So on these machines, the bars, which are those 4-foot length bars that you saw over there,
Yep.
are being held firmly here
Okay.
in what we call a chuck. So that prevents the bar from moving forward and backward along that direction,
Oh, really? Okay.
but it rotates the bar.
It rotates the bar. Okay.
Yep. So the bar will be rotating, and that's when the cutting action occurs. So
Okay.
the spindle is going to rotate the bar,
Okay.
and then this device up here, which is just referred to as the turret,
Okay.
is carrying different types of cutting tools. We
Oh,
have
look at that. Yeah.
drills, and then carbide inserts, which I can show you a few that are out on the table.
Okay.
And those tools enter into the cut. So when the bar is stationary, this device will move down on what we call the x-axis and in on what we call the z-axis.
Wow.
So it's going to move in those coordinated movements programmed on the CNC to form the shapes that we have.
Wow.
And on this particular machine, we have a secondary spindle that allows us to grab the part from the main spindle when it's done and perform work on the back. All the movements that the machine is going to do has at some point been programmed by a programmer.
Wow.
So there's a series of different codes. We would need a lot of time to go over it,
Yeah.
but typically it's referred to as G and M code programming, where G codes control all movements and M codes control all auxiliary actions, like turn on your
details.
coolant or
Oh, really?
rotate the spindle. Checking a part that size has some challenges, because we have a series of tools here, just hand tools that we use to check things.
Oh, okay.
But if the part is bigger than the size of the tooling that you have, then you have to come up with other creative solutions.
Oh, brother.
Yeah, so what
Really?
we have over here is it's a brand new piece of equipment that we just got last year. Oh, I'm sorry, beginning of this year,
Okay.
where it's going to check the part optically. So what you're looking at on the display is actually this diameter here. We just refer to it as a diameter. And it's a touchscreen display.
Oh.
So if I want to know the measurement of this,
Yeah.
I can just tell it that I want to grab that surface there and dial it over to the other side. Grab that surface there, and then over here tell it, provide me a measurement between those two lines.
Wow.
and it'll tell me that it's 2 inches,
Oh, look at
370 thousandths.
Wow.
So then we can compare that to the customer's drawings, make sure everything's in tolerance. So it's a really nice feature. What's great about this one is after we do this once, you can store the movements of the machine so that it will do it on its own next time around. So
really?
you kind of, yeah, you increase your productivity. People can, we haven't yet utilized it to that level because it's new to us. We've got to
really?
learn it, but
Okay.
I'm excited to see where we go with it.
Really
Yeah.
impressive. Wow.
So I was thinking the next thing that we'd look at is we would go right over there and take a look at what a milling machine is.
Oh, the milling machine. Yeah, definitely.
So right now, the main differences between the two is over there, the workpiece was rotating and your cutter or your cutting tool wasn't. It would
Okay,
just be
right.
forced into the rotating bar and that would
Yeah.
generate the cut.
Yeah.
Over here, it's the reverse. Your workpiece is held stationary
Okay.
and your cutter is rotating. So right now it's hard to see, but that's rotating at probably 5,000 or 6,000 RPMs.
It is right now?
Yep.
Oh, wow.
'Cause we were going to try to do a quick demonstration of how it moves.
Yeah.
On all of our equipment, they all move using axes.
Oh, they do.
Over there, we had X, Y, and Z. This
Yep.
has X, Y, and Z as well. So similar programming. We're using
I see
G
it.
code, M code. So at this point, I could hit play on it and kind of give you an example of what to expect with the machine movements.
Oh, that'd be great.
It's going to take a slight cut, but
Okay.
nothing that shouldn't affect our ability to film
Okay.
it. So.
Ready to film this? This is great.
So you can see right now the cutter is stationary. It's
Yes.
kind of deceiving to look at, but it's the table that's moving the part around under it. All the cutter's doing at this point is rotating.
Really? Wow, look at that.
And then if it needs to change what we refer to as the depth on the part, you'll see that Z axis will move down.
Oh, okay, yep.
Yep.
Wow.
Just a brief recap. We looked at the CNC lathe. We looked at the CNC mill. Now we're going to take a look at those types of machines over there, which are CNC Swiss lathes.
Oh, okay, Swiss.
Swiss lathes, yep.
Okay. Oh. Yeah. Wow.
Yeah, it's going to be in cut for probably another minute or so, and then
Okay.
I'll be able to open the door and show you
Oh, all right.
more specifics of it.
Wow. Okay, here we are.
Yep.
Look at that.
So
Oh, look at that. Wow.
we have two different work zones that are happening here.
Yeah.
You have our main spindle area,
Okay.
where that is going to rotate that bar, very similar to what I was
We saw
showing you over there. Yep.
Yeah.
That's going to rotate the bar. The cutting tools are going to move into position to shape the part, however we need it shaped.
Okay.
And the material itself is going to move into the cutter. And that's really the main difference between a Swiss style and a conventional lathe.
Okay, so the part is moving.
Right, yeah.
Okay.
Over there, the cutting tools move
Yeah,
and the part
yeah.
stays. Over here, the part moves and the cutting tools stay.
Wow.
It's really the main difference of it.
Wow. Huh. This is really impressive. It really is. I just, wow. Impressive.
Yeah, and again, just scratching the surface. So,
Really?
I mean, these machines make up, I think, I mean, I could be wrong here, so don't quote me on this, but
Yeah.
a majority of what the facilities local to us are using. But yeah, there are so many different other styles of machines out there. Yeah, and our workstations are set up very similar to what we saw over there, where we have a blueprint that we're attempting to follow, right? So I just got to kind of blank that out, any information on the top.
Right, yeah.
We're programming off the drawing, and then once the machine's up and running, we're inspecting to the drawing. So I don't have a complete part over here, but
Yeah.
this is one of them that we're currently making. It was we
at that.
cut it in half to be able to check the inside features of it,
Oh, okay, yeah.
but that's right there is, it won't sit on its own,
Oh, okay.
of course.
Oh, look at
That's what
that.
we're doing, so,
It's so detailed.
yep.
I mean, it has to be exact too, right? I mean,
Yeah,
you're
we're-
doing exact.
We're working with very close tolerances.
Boy.
I think last time I checked, they consider a human hair to be about 3/1000ths of an inch.
Yeah.
And some of the features that we control on here are, so 3/1000ths in a decimal form would be 0.003.
Yeah.
And we're holding tolerances out to like the 0.00001, 2. So we're in the tenths. So we're in like,
Really?
I don't know what that would be, maybe a hair cut into 30 equal pieces kind of thing.
Whoa.
So
Wow. That's crazy.
yeah,
It's crazy.
it's the level that the machinery has come to with advancement. Yeah, so I thought we could take a stroll down that main aisle there and take
Okay.
a look at what we do with the parts after they're machined.
Oh, I love that. That's great.
So these two rooms are our finishing department,
Okay.
and what we do in each room is a little different. So that smaller room will perform what we call tumbling operations, where after we cut all the metal, there might be sharp edges, things that we need to address before they get to a customer. So we'll put them in different devices that are in there that we'll look at in a moment, and that'll help kind of break those sharp edges down, change the surface finish texture, different things that the customer might want us to do.
Okay, great.
And then over here, well, behind me, this is our wash system. So,
Oh, looks hot.
yep, I think around 150 degrees each of the first two tanks are, and then there are different ranges throughout.
Oh, okay.
But what this system does is each tank does something a little different. So the first tank uses high heat, but also this cascading type motion where as the oils are coming off the part, they'll float on the top of the surface, and then they work their way over so that later when we move the parts out,
Yeah.
they aren't being carried through all the oil.
Okay.
And there's a hoist on the end of the machine that's going to do all the work for us. So it'll come and pick up what we call a basket of parts. It'll load it in here. And then when it goes into there, it'll use ultrasonic technology to further clean the part.
Okay.
And then we have a couple rinse tanks down the end.
Really?
Yep. It's, I think right now, so the display over here shows you the level of cleanliness that you'll achieve in the final tank, which that's, I believe that's 1 micro Siemens per centimeter, which
Oh, interesting. Can you check that out?
the conversion of it, I'm not sure. We typically register things in like a parts per million scale, but I don't think I could accurately quote what the difference is there.
Okay.
So if you give me 1 second, I'll grab the gentleman that works out here, Roberto, and he could place a basket on there and get it running.
Yay.
He's told the machine now what type of part he's about to clean, what program to run, program being like which tanks he wants them to go into, for how long he wants them in there.
Oh, really? Huh.
And then it just takes a moment to kind of communicate it to the hoist, but it'll come over, grab everything, and place it in.
How do you know how long to put something in, or what tank to put it in? How do you know that?
Well, for repeating work that we've done before, once we develop a process, we document it so that we can then later repeat the process over and over again. And then for new work that comes in, Roberto will coordinate with one of us, kind of determine what the best process will be given our history, the different components that we've washed. You get a general idea of the best way to go about doing something.
Oh, okay. So here it goes.
Yep, so from here on out, any time that the operator needs to spend at the machine is very limited, because it's gonna carry it through to the end and place it on the green dock that's on the other side of the machine.
So that's the pre-clean.
Yep. The cycle will take approximately 1 hour to get from there to
Oh,
the
it
other
does?
end. Yep.
Really?
So,
Oh, I thought it was like 5 minutes, you know? Boop, boop, boop,
no.
done.
no, it's going to sit in this first tank for 15 minutes, and then
Really?
each tank's structured a little different, to really make sure that we get
Totally
Yeah.
oil off.
all the oils, any particulates, everything's gone.
Yeah.
So,
Wow.
in this room right over here, thank you, Roberta.
Thank you.
I won't turn one of these on because it's going to be really loud.
Oh,
But this would be one of the devices that we would use to break the edges of a part off.
oh.
We would
really?
place them into these, and they're referred to as a vibratory tumbler. And this thing is just going to shake
Yeah. Huh.
at a high level.
Okay.
And what we put in with the parts are what we call media, which are, I always like to consider them as like a sandpaper, but in a three-dimensional form. We have them over here to show you some examples. So if you can imagine dumping, one or
look at
two
that.
of these bins into there with the
Yeah.
parts,
Yeah.
there's color differences between the stones,
Oh, look
and
at
there's
that.
shape
Oh.
differences. For the most part, the shape difference is just a preference if you need to get into any tight corners or
Really?
particular features on a part. And the color differences are like how aggressive the stone is at removing it, like using a 600 grit sandpaper or a 100 grit sandpaper. So your white stones are for polishing, your blue stones are more aggressive, your green stones will really take edges down.
Really.
So
Now, can you reuse those, or do they, how does that work?
you can, yep, we can reuse them. They do wear out over time because as they're beating up the parts, they're also getting beat up at the same
Yeah.
time. So
Yeah.
it's not uncommon to take something that starts off like this, and it would become that over time. That's
really?
That's the same stone. So
Really?
yep.
Wow. Isn't that impressive? Boy, to know what does what is just amazing.
Yeah,
that's-
we've worked hard
Yeah,
to
yeah.
keep track of everything.
Yeah, look at that.
All the part numbers to order. It really
Yep.
makes everyone's job easier when
Sure.
you have an organized system. So
Yeah.
we use this benchtop area as kind of like a multi-purpose department. Sometimes we're doing inspections of parts. Sometimes we're doing assemblies. Sometimes we're sorting parts if something went wrong on one of the machines. So it serves a multi-purpose. What we're doing right now is an assembly of a product that the owner and the owner's son have designed, followed through, marketed, and now it's a product that we actually ship internationally.
Oh, yeah?
Yep. So all of the components, all of the machined components are made here in-house, and then assembled and tested by Roberto. Do you happen to have one, Roberto, a complete assembly? So what we're assembling are tire deflators, which are
Wow.
specifically targeted for like off-road enthusiasts, those that fish, or if they're going to be doing any type of driving their vehicles on sand, muddy
On the beach or
areas.
something?
Yeah, to lessen the environmental impact.
We set it up in 15.
Yep. So the air tank is kind of simulating a tire, filled with
okay.
air,
Wow.
and on the
Wow.
Yep, but every one of these
Isn't that
components was all made here on different machines.
Look at that.
Yep,
It's so detailed.
and they all get assembled together.
Look at that.
So this over here, all those is gonna be like this.
Oh, look at that. That's the final thing. Okay.
Yeah, when you put those together, it's gonna be
Yeah.
gonna get this one.
I love it.
And I'm doing over there. I'm doing this part.
Oh, okay. So over there you're doing that.
Yeah,
Okay.
we do a three-step process on it. So he's assembling the body in one operation. He's assembling the upper portion of it in another, and then in the third and final operation, he's testing them to make sure that everything works. So
Yeah, we put it together and test it.
Every single one.
Every single one.
Wow.
yep.
Oh boy.
We're creatures of habit.
Very good.
So the final room that's right over here is Swiss machines as well. What we looked at over there, they're just a smaller version of it.
Oh, okay.
If you'd like to go out and take
Sure.
a look, I think some of them are running right now. So.
Let's go look.
So an example of a couple parts that we have running on these machines. So these machines will max out at a 3/8 diameter bar. And that's really how all the machines are rated, by their diameter capacity that they can work with. So 3/8 and under we can do on these machines. 3/8 and over we have to go
The
out
other
onto
ones.
the other equipment.
Oh, okay. All right. Wow, it's so tiny.
Yep.
It's really little.
But all the machinists, myself included in the building, we all follow a same process where we're developing a program, we store it on a network, we create what we call setup notes that'll let us know if we get this job back next year, how we did it successfully the first time.
Yeah, yeah.
And we keep all that information stored. So
Wow, it's amazing. Well, thank you so much, John. This has been incredible. I have enjoyed it thoroughly, and it's just wonderful. And Mike did a great job as well. And really, this place is great, and I have learned so much. I really have, and very impressed. So thank you.
Well, thank you very much for coming by. We appreciate you getting the word out and the any opportunity to show people what we do. And we love to. We just love what we do, and we love to share and have people learn about manufacturing and really what it's all about today.
Yeah. Well, thank you very much. I appreciate it.
You're welcome.
Well, until our next episode, have a great day, and we'll see you next time on Discover Easton.